Thank you so much, Howard. You've been wonderful. Howard is correct. Can everyone hear me? My name is, in fact, Matt DiCarlo. I work at the Albert Shanker Institute. Do primarily quantitative research. I'm very honored to be joined here by this distinguished panel of experts and luminaries in the field. I actually think that this is the only teach session on value added, and you will notice that I'm up here alone. If you are a public school teacher in the US, chances are you're either already being evaluated, or at least tested teachers in your district already being evaluated using value added, or are in the process of doing it. And that's the context in which we'll be discussing it today. Every time I present to teachers about value added, which I've done a bunch of times, there's, shall we say, a lot of skepticism in the room about value added. Typically, a lot of people have kind of this face on, or they're looking at each other like. Part of this, I think, is probably my charm and charisma. But I think another part of it is that I'm not going to sit here and tell you value added is awful and it's going to destroy your schools. Nor, of course, am I going to tell you that, if we put value added in, we'll be Finland in 2 weeks, because that would be uncomfortable for the Finns and for us. I am going to tell you, kind of present both sides of the case here and argue that value added has a lot of serious problems, but also has some potential. And that is, of course, what my teachers always said about me. Basically, that it is a useful tool if used properly, potentially. But certainly, whether you love it or hate it or are indifferent towards it, it's always good to have both sides of the argument, have a full set of information. And I know that you as teachers and trade unionists agree with that. Now, in that spirit, my basic strategy here is I'm going to be discussing value added in the context of evaluations, in the context of the most common objections that I hear raised against it. This is kind of an argument with myself in some respects, and that kind of mix of futility and self-absorption fits in nicely with my personality, arguing with myself. Because even after these many years with value added, I still hear a tremendous amount of misinformation about value added, and it comes, I'm sorry to say, from supporters and opponents alike. And in part, the fact that there's misinformation makes sense, because value added is very complicated, right? You guys are teachers or local presidents, you have real jobs and lives and things to do and friends. I, on the other hand, gave all those things up for Lent in 1982. So some of this explaining value added to you may be review, some of it may not be. But hopefully you'll walk away from here realizing that the issue of value added in evaluations is nuanced. And really the only kind of questionable, unsupportable position at this point is certainty, either way, about what's going to happen. So I'll be keeping this simple and accessible. I may use a couple of words like error margin or covariate, or as I call it, pillow talk. But we'll be very non-technical, and we will have some fun, hopefully, because I am a very, very fun guy, if you can't already tell. But the first step here, I think, is that I'm going to lay out some framing issues. I do use PowerPoint. It's available if you want it on the app. I'm sorry I don't have them printed, but I'm negligent. You don't have to read it. I don't read my slides. It's a memento of our time together. So if you want it for you, it's for you, so you remember what I said. Kind of summarizes what I said. It's like notes. You don't have to take notes, so you can look at the eye candy that is me. So a few framing issues. It's unbelievable to me how much attention value added gets in the context of the teacher evaluation debate. The debate about evaluations is, in some respects, largely about value added. Yet in reality, only a minority of teachers is actually eligible to receive value added. These are teachers, of course, in tested grades and subjects, and value added is only one component in most of these new evaluations. Now, the reason that it kind of sucks all the oxygen out of the debate, I think that there are a bunch of reasons. One of them is It fits in. It's a perfect symbol of test-based accountability, of which many people are tired and other people are kind of very enthusiastic about. It's also true that the push towards improving teacher quality, if you will, was in many respects based on, inspired by, we'll put it that way, the literature, the research literature on value added. And that research literature is actually very, very well developed, far more so than it is about other components that are being used in teacher evaluations. And it's really kind of confirmed a lot of what we thought we knew about teaching, and that's what good social science does, right? It looks at things that we think we know and confirms or doesn't confirm them. And the kind of core finding out of the value-added research is that not all teachers are the same in terms of their impact on test scores, for whatever that impact is worth. There's a big difference between the top and the bottom, and that's not something I think strikes a lot of teachers as controversial or as something that doesn't match their own opinions. Not all teachers are the same. There are good teachers, bad teachers, and to the degree effects on test scores, estimated effects on test scores are a proxy for that quality. I think that the fact that there's variation in performance is not really that controversial. With that variation, however, comes this incredible allure that a lot of people feel that if there are these big differences between the top and the bottom, and if we can just move things up a little bit, there can be these tremendous benefits. And I think that really has a strong allure for policymakers, for elected officials, and for administrators and teachers. But we should, I think, remember that value-added models have many uses beyond and before just being put in these new teacher evaluations. This includes the evaluation of policies, like professional development policies. This includes using value-added for informational purposes. And I think that we should be careful not to judge the entire enterprise of value-added simply because we don't like one way in which it's being used. So I don't like when you put fruit on cake, but I still like fruit. But I like cake more. So we have this kind of strong body of evidence on value-added, but the research on how to use value-added in evaluations and what will happen is extraordinarily thin, in part because this stuff is kind of brand new by policy standards. Nobody really has a strong idea of how to use value-added in evaluations or what will happen, though you wouldn't necessarily know that from listening to people talk about it. And a lot of people kind of conflate the research on value-added overall with the differences between the top and the bottom with this idea of taking these models and applying them to individual teachers and putting them in these systems and attaching stakes in part to the results. And finally, just one little thing. A lot of people talk about value-added like it's just one model, like it's the formula for Coca-Cola, but there are, in fact, many different specifications. And in fact, there's no solid dividing lines, but value-added is technically just one type of growth model. A lot of states are using other types of growth models, but the results vary between these models. The characterizations sometimes vary, so be very careful about making any generalizations about value-added models for that reason. So that's just a little safety tip. I don't want to get into the whole how models work. I used to have a whole thing where there were animations to the degree I could make those animations work. But there are some generalizations, and I think it's, just briefly review the nuts and bolts, sense. The focus of value-added, of course, is not on how highly or lowly students score, but rather on the progress that they make over time. The focus, the idea here with the progress we're making over time is we're making causal inferences here, right? This teacher had this causal effect on student testing growth, and causal is a very strong word. It's a very sacred word. And to make those inferences, we have to set expectations for student growth against some standard, usually the average in the district or the school, and we do that using available characteristics. The most important characteristic for a student is his or her testing history. Most notably, almost all growth and value-added models, I'm just going to say value-added even though it's one type of growth model. Almost all growth models include the student's score in the prior year. That's the most important. It picks up, transmits a great deal of information about that student, And students who start at different levels tend to make different rates of progress. But the general idea here with the causality is to purge all the non-teacher effects from the data, and whatever you have left over is attributed to the teacher. You can include other variables as you see fit. There are plenty of choices, including tests in previous years before the last one, tests in other subjects, and of course the standard litany of educational variables. So, but again, teachers whose students exceed expectations get high value-added scores. Teachers who don't get high value-added scores. Now this is, of course, an extraordinarily complex endeavor, all right? Which is why when the New York Times published this equation in 2011, I think it was embedded in a New York Times article. Basically, everyone freaked. Today, you can see this equation everywhere. Search for value-added equation. This is the first image that comes up. And it's typically, you'll have a teacher writing an essay or something, and there'll be something like, I help my students 24 hours a day. I help them with their problems in their lives. I make a difference in their lives. I help them with their emotional problems and their problems at home. I help them learn through all these troubles. But this is how my school and district wants to judge me. And they put the equation at the end, and it's kind of like a joke. Sometimes it works, sometimes it doesn't. But it's become kind of this symbol to many teachers of this kind of ridiculous complexity of value added. And I think that general idea of complexity is important beyond, of course, this one example. Now, on the one hand, I do respect that reaction about the kind of, this is too complicated, it's ridiculously complicated. I think a lot of non-teachers fail to appreciate how they would react if someone told them, we're going to judge your job performance using these metrics that you don't necessarily trust, and this model that you don't really understand. I mean, you hear a lot of people say, teachers should be held accountable just like any other professional, right? Yeah, okay, that's fine, but there are a few professionals that get judged based on something like this, but not that many, and it becomes a kind of, I think people fail to appreciate how they would react. I mean, if you told me, we have this statistical model and we're going to judge your job performance with it, my first reaction would be, how did I do? And they would say, you did poorly, and then I would say, well, that's because it's flawed. If they said you did good, I'd say, that's interesting. On the other hand, there is something to be said for complexity, all right? We're talking about teaching is very complicated. Student learning is extraordinarily complicated. I don't have any children myself, but I've seen them in the grocery store, and the idea of trying to explain their learning processes, why they do what they do, their behavior, strikes me as rather daunting, and I think maybe complexity is called for in that situation. I think it's actually maybe a little more insulting to judge you based on subtraction. I won't name any names, NCLB. And don't make fun of equations. This equation actually isn't really that bad, all right? Just so you know, but we won't get into that. So before I start my argument with myself, I have three premises. I don't think they're controversial, but you can tell me what you think. The first and most basically is that teachers should be held accountable. This basically means we should have teacher evaluations. We can't reach this impasse where we say, forget it, no evaluations, we don't need them, and we walk away. We have to come up with some kind of system. Second, there are going to be mistakes. What this basically means is you can't tell me some measure is no good because it makes some mistakes, because it generates some errors, because any measure worth anything is going to generate some errors. It's only a matter of degree. It's a matter of finding that kind of level of tolerable error. And tolerable error is, of course, very important to me in my marriage. My wife keeps having to raise the tolerable error bar. She looks at value-added error rates and she just goes, that would be great. Third, I think, and most substantively, you have to assess all these measures relative to alternatives. Again, you can't tell me that a measure is no good because it has this property or this characteristic when every other alternative also has that characteristic or property. So if, as we stipulated, we have to hold teachers accountable, that's the first premise. Then we have to choose measures, and we can't just dismiss one if we don't have any backup on it. Okay, so let's move into my argument with myself. the first criticism that I hear all the time, one that perhaps I assume many of you are familiar with, is that value-added is unreliable. You can't trust these. You can't trust value-added any further than you can throw it. Now, I think most of you know the difference between valid and reliable, but I hear them confused sometimes. So reliability is about the precision of measurements. If you measure something over and over and over again, will you get roughly the same number? So if I weigh myself 10 times over the course of the day, I'll be very depressed, but I will get maybe plus or minus a pound depending on the time of day and what I've eaten. That's a relatively reliable measure. Validity, on the other hand, is about whether these measures are telling us what we think they're telling us. So with a scale, it's kind of straightforward because you know you're weighing, it's telling you how much you weigh, unless, of course, that scale is light by 10 pounds, in which case you have a validity problem. No matter how many times you weigh yourself, you're going to be light by 10 pounds. That's about validity. Are we drawing the correct conclusions? Of course, some people might not have a problem with it being light 10 pounds every time, but that's what validity is about. So in the context of value-added, reliability, the argument about reliability is that value-added is measured imprecisely. True, period, end of story, all right? Part of this is because tests entail measurement error, but another part of it is because classes are small, and so samples are small, and so 1 or 2, 3 anomalies, kid tanks the test, does very well, can really have a big effect on a teacher's score, simply because there aren't that many students in the sample. As a result, you find that value-added, as is well known, and that I hear a lot, have these kind of wide margins of error, which we'll discuss. Students, kind of the way you can think about the margins of error is that students are kind of spread all over in terms of their performance rather than right in one place. And so, of course, if you have this error in any given year, we find that value-added models are very jumpy between years. They're unstable over time. This is a big, huge problem for accountability, especially high-stakes accountability, where you're attaching consequences to these measures. Yes, there will be mistakes, but value-added is often portrayed, and not without merit, as too many mistakes. This is a ridiculous error rate, and we can't use these things in accountability systems. Now, of course, we should note that this error of precision plagues all accountability systems. It's just kind of part of the deal. It's not specific to value-added, but perhaps is more salient in the value-added case than it would be in, say, the school accountability case, because we're taking those classrooms and moving up to schools. We're taking the school-wide sample, moving down to individual classrooms, so the samples are smaller. So let's illustrate this very important concept of error by looking at some videotape of me from my interpretive dance class. Let's look at these fun little graphs are a nice illustration of how error works. So on the left, you have teachers' value-added scores sorted and then arrayed by rank. So we have 300 teachers. I think these are 4th grade teachers in math, I believe. So each dot is a teacher. They're sorted. Those are just the raw scores. And on the right, we have what's called a caterpillar graph. Those little caterpillar legs are what are called error bars or confidence intervals. So you can think about this much the way you think about a political poll, where they say, this elected official has an approval rating of 52% plus or minus 3 percentage points. What that means is that we can be confident, statistically speaking, that the truth, this politician's true approval rating, lies somewhere between 49 and 55, because it's 52 plus or minus 3, right? Now, to be clear, something that I think is often ignored is that truth, which we can't observe because it's invisible, that truth is much more likely to be towards the center, towards the original dot, than it is on the tails of the error margin. So it's not like it can be anywhere between 49 and 55. We don't know where it is. We have no clue. It could be anywhere. No, it's much more likely to be towards the middle. But what you see here, when you look at graphs like this, and this is very typical, is that most teachers, or a very high proportion of these teachers, these error margins cross that middle line, which is the average teacher. That's not the best term, but the average teacher effect is this line in the middle. Most of these error bars cross it. So these teachers get below average value-added scores, but their error margins cross the line. The statistical interpretation of that is that the difference from average is not statistically significant. That's the way you interpret that statistically. Maybe not in a policy context, but that's the statistical interpretation, as we'll discuss. It just means that you can't say with confidence that these teachers are either above or below average. Which reminds me, the only joke I've ever actually liked, the only like pre-fabricated joke that I've ever actually liked is this. 3 statisticians go hunting in the woods for deer, and they spot a deer, and the first statistician shoots, and the bullet misses 5 feet to the left. The second statistician shoots, and the bullet misses 5 feet to the right. And the third statistician goes, "We got him." This is a very classy presentation. Anyway, this is the difference is not significant if that error bar crosses, but what you'll notice here is that these error bars overlap amongst almost all of these teachers, amongst a very high proportion of these teachers. So we can't say, so if this bar crosses any other bar, any other teacher's bar, we can't say, statistically speaking, that that teacher is different from any of those other teachers where those bars overlap. All right? And you'll also notice that these error bars span, the average error bar spans a pretty wide range between the top and the bottom estimated effects. Now, of course, if there's error in any given year, there's instability between years. I wrote stability because it fit, but it's, I suppose you could say, instability. These colors always suck on the screen. Anyway, this is green, orange, yellow, red. This is just one example, but these are just value-added scores for teachers in 2 consecutive years. In both of these years, these teachers' scores are sorted into quintiles. So bottom 20%, 20 to 40, 40 to 60, so on. You do this in both years, and these are cell percentages. So 4.2% of teachers in this particular sample got the lowest quintile in year 1 and the lowest quintile in year 2. These are just 25 different combinations of 2-year outcomes, all right? This teacher, for example, 3.3% of teachers in our sample got the second lowest quintile in year 1 and then the lowest in year 2, right? So these are just all the possible combinations. Now, these are the stable ones on this diagonal shaded in green. If you add these all up, you find that about a quarter of teachers get the same quintile score in both of these years. And if we move out a little bit and say, if you move up or down 1 quintile, that's okay. It could be, I mean, you could actually move up or down a quintile if you go from 19 to 21, right? So it could be a very minor change. But let's just say we consider that reasonable accuracy, if you will. So another 40% of teachers move up or down 1. So 2/3 of teachers are within 1 quintile in year 2 of where they were in year 1, all right? That sounds great, but that also means that 1 in 3 teachers moved 2 or more quintiles, which strikes some as quite high. And then, of course, we have these like extreme examples of these teachers in the other corners where this teacher was top quintile in year 1 and then bottom in year 2. So it's kind of top to bottom reverse Horatio Alger story. And then another 3% of teachers were bottom to top, right? So everywhere you use value added, you always get that story in the newspaper of that teacher who was 98th percentile in year 1 and stuck around for year 2 and ended up in the 3rd percentile. And they have a picture of the teacher in the paper, like, and then there's the whole quotes where it's, I didn't change anything, I used the same lesson plans, I dressed the same, I ate the same for breakfast, everything was exactly the same, but my performance estimate is completely different. You see that story a lot. But anyway, to the degree, so if you look at this kind of instability, this is a big problem for 2 reasons. First, of course, it suggests we're making mistakes. So if we fired all of these bottom quintile teachers from year 1, which is 20% across, of course, because they're quintiles, a large proportion of them, I think 1 in 3, if you add it up, are going to be about half of them will be quintile 3 or higher the next year. So we will have fired a fairly large group of effective teachers. Second, and perhaps more importantly, with the making mistakes, there's a credibility issue here which we'll discuss. It won't take teachers very long to figure out that this is happening. that this is going on, and it will cause a lot of problems, and we'll get into that. So overall then, yes, please, sorry.
Are you taking questions now or later?
I'm sorry, I don't understand.
When are you taking questions?
Anytime.
Well, I have two questions. Can I take it now? Can I get them now?
Sure.
I'd like you to tell us what are some things I should be doing in the classroom that I could say that can predict success, higher performance, that I can see as value added.
Okay.
And two, based on the numbers, what are the algorithms I put in there to get those numbers?
Okay, the first question the potential risk of asking a question in the middle is you risk me saying I will be addressing that later, and I would ask that you bear with me until I do. As for what the models are, I didn't go into the detail how the models work kind of under the hood, nuts and bolts. We can go into that later. If you'd like, you can approach me afterwards and we can discuss it. Suffice it to say that it's based on expectations of the average student in the district or the school. If you want to look at it one way, if you have a student who has all of these characteristics and scored a 50 on the test last year and is special education and not eligible for free lunch, you look at all the other students that have those same characteristics, scored the same last year, had the same characteristics, how much progress did they make over the course of the year? Any difference between that and the student in question is attributed to the teacher. That's a kind of very short, simple way to put it, but the details of the models are something that we can discuss afterwards. You were going to go enforce Lynn to the rescue. So again, I'm sorry to defer on that question, but if you want to discuss the kind of nuts and bolts, definitely we talk afterwards. I left it out because the focus here is on value-added's use in evaluations, and so I wanted to talk more practical policy. So overall, this kind of imprecision, this random error, is a big problem for value-added in accountability systems. I would argue it's a much bigger problem than validity, which we'll be discussing later. High stakes and high noise are a bad combination, and anybody who tries to downplay this or tell you it's not a big deal is making kind of another type of noise, and that's just not accurate. Okay, however, and this is where I start to get annoying, and maybe many of you are saying, what do you mean start? But this is where I start to get annoying. There are some things that we need to clarify when it comes to random error. Even if value-added models were perfect, all right, there would still be some instability, some error within and between years, simply because we have small samples. Conversely, even if we had a perfectly reliable, stable measure, that measure is not necessarily a good performance measure. Indeed, probably is not. So if you have observations, or every teacher gets the same score every single year, that's a perfectly reliable measure, right? But it's also kind of a useless one. So we have to be careful not to over-fetishize reliability. Like all fetishes, it's best to keep it in perspective. Thank you, sir. Second, unless you believe that your performance as a teacher is fixed in stone from day one to the day you retire, some of this instability between years is real, right? Teachers improve, or teachers get worse in some instances, and so we should expect some instability. So be careful not to just assume that if these estimates change over time, that's error, because some of it is actually real. If you measure your kid's height over the years and it goes up, you don't question the ruler, though in my case, I grew 11 inches in 1 year. They were questioning the ruler. I actually have this very, very clear memory from childhood of my family saying, that can't be right, and they measured it like 5 times with the ruler, and I was this wise-ass kid going, it's not the ruler. It's not a reliability problem. But I have that clear memory. I don't remember a lot from my childhood, so that says a lot about me as I remember stuff like that. It's the measurement that made my childhood special, the measurement issues. Third, and now I'm really starting to get annoying, what are your alternatives here? What we're finding is with these other, these new observation systems, is that with the Danielson framework and another framework, you may not like them. You may like them, but they're not just thrown together. They're respected, accepted observational protocols. What we're finding is that these observation scores are also unstable to a degree between years. They're also jumping around. And by the way, for in many respects, the same exact reason, because you've all had a bad day. You only get 1-2 observations a year, 3 at most. You've all had a bad day. You maybe not get a lesson that you're comfortable with. Maybe your kids are acting up on a day, and since you only have one shot at it, that's a small sample, and so it might fluctuate if you measured it multiple times. But we're also seeing this jumping around, and so if you are going to say value added is unstable, so we can't use it, you have to come up with an alternative, and you find that the alternatives are exhibiting the same characteristics. And by the way, if you don't like my performance today, you should have seen me last year. Shut up, Lynn. All right, I'm going to do this very quickly. I just wanted to say here that there's a lot of imprecision and instability between years. That's very important. Let's not imply that it's random. It's not random, okay? There is a positive relationship between years with value added. It's modest, but it is positive. Of course, that's really just saying value added predicts itself, but that is, I do hear some implication that it's random. Some also argue that the most important outcome is whether value added in 1 year predicts your career value added, as opposed to whether it just predicts the next year. And you find that when you do that, the red bars, you actually get more stability than when you compare it just 1 year to 1 year. So there is kind of signal and noise with value added in terms of the reliability angle. But this is my most important point about reliability, and that is that we're not helpless when it comes to these precision issues. We don't have to just sit there and take it. There are things that you can do with policy design. The decisions about whether and how to do so, and we'll discuss a couple of them. I'm just going to take my fellow panelists' water, so I'm just going to keep moving down, whichever one I'm closest to. You guys don't mind, right? All right. I love these guys. The decisions about whether and how to address error all entail trade-offs. We'll discuss a couple of them very quickly, but we can help this situation, and that's true whether or not you may not like value added, you may not want to use it in evaluations, but in a lot of places you don't have a choice. It makes sense to do it in a sensible way. And to be completely honest with you, it's not entirely clear to me that a lot of places are taking steps like the ones that we're going to discuss. And that bothers me. I'm not going to talk a lot about what states are doing, what some states are doing, what other states are doing. Perhaps my fellow panelists would like to weigh in at some point. I'm not going to get into it. But one of the things that you can do, let's just move into a couple of, these are very simple suggestions, not exhaustive, but just things that you can do. One of them is that if sample size is bothering you, you can increase your sample, right? There are different ways to do this. You might, for example, require that in order for a teacher's value-added score to count towards that teacher's evaluation, there has to be 2 years of data. There have to be 2 years of data, right? Or you can do it kind of optional, where you say, we use 2 years of data when it's available, because it's not available for our teachers, but we'll use 1 year if it's not available, or something like that. But the point here, in general, by the way, the kind of improvements to reliability you get from adding additional years, of course, it's just adding additional students. So it really does depend on how big your classes are in each year. But the payoffs kind of level out after 3 years. But this has a big effect. So if you just do 2008 value added, 2009 value added, each red dot is a teacher. If you're a teacher, you're a red dot. This is New York City, I believe. You see that the relationship, if it were stable and perfect, all the teachers would be concentrated on the black line, right? Because their value-added score in 2008 would match their score from 2009. Instead, we have this kind of, not such a good paintball target shooting person where there's kind of a circular, there's not a real visible relationship. It's a rather weak correlation between years. If, on the other hand, you use multiple years of data, yes, there's still noise, but you see these things really press in on that diagonal line. And you get a tremendous improvement in terms of stability. Now, of course, there are downsides to this. You lose the ability to pick up on kind of year-to-year variation if you pool between years. If you require multiple years, you're going to make some of your teachers ineligible to receive value added. If they only have 1 year and you require 2, they can't get the scores. So there are costs here, but I would argue that there's a payoff that's worth it, especially when there are high stakes attached to these outcomes. If you ask me personally, I see a teacher with a really low value added score 1 year, putting aside the kind of, it's all tests issue, I say, maybe something, I don't know. I'm not really that impressed. You show me a teacher that has, 3 or 4 consecutive years, I say, I'm not passing judgment, but I'm saying, there's something there. There's enough evidence that this teacher should have some kind of additional intervention. We should look at this teacher. There may be a problem. And finally, there is a statistical technique called shrinkage, where the estimates, this is kind of baked into the model itself. The estimates are adjusted according to sample size, which we don't need to get into the details, but it really improves the precision by adjusting the estimates according to how many students they're based on. This is something that some states and districts are doing, most are not. It's a good idea in lieu of or in addition to what I'm talking about. Another thing, I'm doing this one very quickly because of time, because we got a late start. One of the nice things about value added is that unlike observations, you actually get a measure of imprecision with value added. We could get the same thing. We get those error margins, you remember, from one of our previous graphs. You would, by the way, get the same thing from observations, but for the fact that there's only 1 or 2 of them a year. If we did 30, 40 observations a year or 20, you could get a margin of error on them, but if you only have 2 in a year, it's tough to get a measure of imprecision. But value added does provide that information, and this is information that can be used and might be useful. At the very least, should always be presented to teachers and principals who receive their scores. But what you can see here in this graph from New York City is it varies by subject and how many years of data you have, but most teachers' estimates, anywhere between half and 4/5, are, like we said before, crossing that average line, the error bar, which means they're statistically average. Now, this doesn't necessarily mean we should convert value-added scores into a 1 to 3 point scale, but there are ways to use this information, such as, for example, just simply distinguishing between teachers whose estimates are statistically significant above or below 0, or, for example, not cutting the point thresholds right in the middle of the distribution where error is largest. So just to sum up reliability, value added is imprecise. Within and between years, this is a big, big problem for the teacher level use in particular. It's also a problem that's suffered by other measures, and there are things that can be done about it. Some states are pretty good about it, others are not. I'm not going to be naming names, but there are things that can be done, and I don't get the sense that they're necessarily being even considered in all places. I think maybe, I don't know, just to speculate, some officials feel like if they come out and address error, it's almost like tantamount to admitting it exists, and that'll cause problems. People may say, well, if we have to put these error margins in, why are we using these measures in the first place, right? But in any case, I think more can be done on this issue and that it should be done. And this is a good example of how, when I say it's not to me whether value added is good or bad, it's about how you use it. And this is one of the things that frustrates me in some places. Second criticism, value added is invalid. It's not telling us what we need to be told. It's not telling us anything about teacher quality. Now, in the kind of technical researchy sense, validity is about whether these estimates are unbiased causal estimates of teachers' causal impact on student testing growth. So it's kind of specific. We'll be kind of using a more expansive definition of validity, but one kind of interesting way to think about the validity of value added, well, interesting in my book anyway, and my book is very, very interesting. If students were randomly assigned to schools and classrooms, we wouldn't need value added. Now, some of you may be saying, oh, a world without value added, that sounds wonderful. That is, it sounds utopian until, of course, you consider the logistical challenges of randomly assigning students to schools and classes, but that's a different story. There would be a large bus strike, I suspect. But anyway, if students were randomly assigned to classes and schools, we could be confident that any differences between teachers in terms of their students' testing growth were not because some teachers had some students and some teachers had other students. We would still need, with a large enough sample, all right? If it were just a few students, you couldn't make that assumption. But with enough samples, we could be confident that any differences between teachers were not because of the students they happened to be in front of, because we've randomized that. Absent that, however, the basic idea with validity is that the models can't control for everything, which means that some teachers are being judged based on the students they serve, not based on their actual performance. One very commonly cited symptom of this is you'll hear a lot of people saying value-added estimates vary systematically by the students that are in a teacher's class. So teachers who have more disadvantaged students get lower scores, and vice versa. And you hear this all the time. But anyway, with the validity, it means we're going to be making mistakes regardless of sample size, and holding teachers accountable for factors that are out of their control. So here's a very simple example. You can ignore these for now. These are two very common value-added growth models that are being used in evaluations. And what you see here basically is this is the average value-added score, or percentile rank, of teachers who have advantaged students in their class, average students in their class, so to speak, and disadvantaged students in their class. And you can see that the average value-added score, or percentile rank, declines as students become more disadvantaged. And you see this in a lot of places with a lot of different types of models. So teachers who teach more disadvantaged students tend to get lower value-added scores as a result. This is surface evidence of what you might call bias, of a lack of validity in these measures. I mean, my mother heard about it, and she was a teacher for 35 years of special education students at an alternative school, and she just, she said, well, you can't control for who's on a special education plan. They're all different, and some of them are more severe than others, and it varies. And she ended up getting all angry at me, and I said, Ma, I didn't do it. And she said, you're involved. I said, all right, I'm sorry. She goes, I'm sorry too. All right. But anyway, to the degree this represents bias, okay? Teachers are being penalized for teaching more disadvantaged students. That's also a big problem. It not only means we're making mistakes and penalizing, by the way, teachers that we should be rewarding, but it also adds to what we'll discuss, which is a credibility problem. Again, it's not going to take teachers long to see this. If they find out they get lower scores by teaching disadvantaged students, they will not want to teach those students within their schools. They will switch schools and districts to avoid those students, so on and so forth. It's just a basic big disincentive. These schools that serve disadvantaged students, they already have problems with retention, working conditions, so on. This is just making it worse. Look, we all love teachers. You guys are, saints. But you're also human beings, and you consider your working conditions and your compensation when you make employment decisions, okay? If you work in a disadvantaged school, on average, you're more likely than not dealing with a lower kind of, with worse working conditions, many exceptions, but on average, working conditions are worse. You probably get paid less than the teachers kind of in the suburbs around. And then if we add this other factor where you might get fired, that's going to push people over the line in some cases. So, teachers are saints, but you do consider, your working conditions, and you do behave accordingly. No good deed goes unpunished is supposed to be ironic, not a kind of human resource strategy. Another real quick one is, if we expand our definition of validity, we might ask, do value-added measures match up with other measures, like, for example, observations? The short answer, this is from the Measures of Effective Teaching project. The short answer is yes, there is a positive relationship, but it's really quite weak, and in some cases, almost zero. As you can see at the bottom there, those are just correlations between value added in 1 year and observation scores the next year. So these are weak relationships. And of course, again, in every district, potentially you have that newspaper article about the teacher of the year in the district or the state who got the bad value added score. And they have the picture of the teacher of the year with the big teacher of the year plaque. And right next to it, the graphic showing the low value added score. And then the quotes from the teacher saying, well, I consider myself the teacher of the year. I don't pay attention to the value added score. But anyway, criticisms about validity and this surface evidence that we've presented is fundamentally about whether value-added is telling us what we want to know about the test-based impact, and then on top of that, more expansively, whether that test-based impact is telling us something meaningful about teaching performance. So we have some evidence suggesting otherwise, and that's a big problem. On the other hand, let's be clear, so annoying DiCarlo. First, and you got to bear with me for just a little more time, remember first that validity is a feature of conclusions that we draw from measures, not of measures themselves. Value-added itself can't be valid or invalid. It's all about how we use it, what conclusions we draw from it, the inferences that we draw from it. There is some disagreement in this research literature, and if you read it, it's really exciting stuff. But if you go through it, you see that there is some disagreement about the extent of bias in terms of student characteristics or other factors like school resources and whatnot. There is some disagreement about the extent of bias in value-added estimates. But the kind of bottom line from our perspective here is that there will be individual teachers whose estimates are biased by the students that they serve, no matter what these kind of higher level debates come out to say. It's very difficult to say which teachers' estimates are biased and which are not. And so we're in this, there are ways to test it formally, but a lot of them rely on this kind of circular reasoning where, value-added predicting itself. But it's worth noting also, I think that moving on, that value-added is associated, recent evidence finds value-added associated with long-term meaningful student outcomes, like earnings and college attainment. The associations are not massive at an individual student level. Teacher effects fade out. There's a lot of imprecision, but we might ask, if value-added measures are telling us nothing, why are they associated with meaningful outcomes? How's my time, Howard? Never mind. Thanks, you've been helpful.
10 minutes, no questions.
All right.
Let's give it 15.
I appreciate that. That's very sweet of you. With regard to matching up between other measures, there's not necessarily any good reason why we would expect all these measures to match up perfectly. And indeed, if they matched up perfectly, say value-added observations, one of them would be superfluous, right? We wouldn't need one of them because they match up perfectly. There's not necessarily a reason to expect them to match up, or even necessarily that we should want them to match up. Perhaps these different measures are telling us different things about teacher performance. And regarding the most common piece of evidence, the association of value-added and student characteristics, we just need to remind ourselves that some of that association is actually real. All right? There are good reasons to believe that teachers who are in, say, disadvantaged schools might, on average, be a little less effective than teachers who are in advantaged schools. For example, disadvantaged schools have a lot of problems with recruitment and retention of teachers. It's not outside the boundary to believe that in some cases the value added would be lower. Some of that relationship may be real. Not clear how much, but don't just assume that because there's a relationship, it's biased. That's not necessarily the case. Some of that is real. Furthermore, quickly, this is for Lynn from Minneapolis. Value-added is not alone in being associated with student characteristics. So if we just go through this very quickly, we're finding this is just one example from Minneapolis, but all over these new evaluation systems, we're finding that the other measures are also associated with student characteristics. Teachers do worse on their observation and other measures who are in disadvantaged schools. It's not just the value-added scores. So in this case, you can see that teachers who on average get higher ratings, well, actually it goes up, higher ratings have work in schools with lower free and reduced price lunch rates. There's also some experimental evidence regarding non-random assignment, but I'm skipping it. Okay, so we can't observe true teacher performance, all right, because we're human. This puts us in a very difficult position of knowing we're making mistakes, but not how to identify which teachers are the mistakes. And anybody who's dealt with me in my personal life knows that the idea of making mistakes and not knowing what they are hits very home for me. It's maybe I'm biased in favor of value added because I have the same problem. But value added is not perfect. It doesn't need to be perfect, just as observations are not perfect and don't need to be. But the validity issue is very important. There are things, again, that can be done about it. The first one, and I'm breezing here, which is good because this is too much anyway. These are 3 different types of value-added models. A downward slope means value-added is lower amongst teachers who teach in more disadvantaged schools. These are actually schools, these dots, but the same thing holds for teachers. You'll find that this downward slope, so yes, value-added scores do get lower as the percent eligible for free or reduced price lunch goes up, so there is that relationship. But if you use this model, this is a very common model. This is another fairly common one, but you see the relationship is a lot weaker. And if you use this model, there is no relationship. It's 0. So again, what I said before is don't generalize about value-added. There are many different models. They produce different results. They produce different results in terms of the correlation. And one thing about weighting, I know that for many of you, weighting was a big issue if you were involved in negotiating. I mean, it was the biggest, the war over value added was about, there were months and months of war over whether it should be 15% versus 25%. Some people seem kind of shell-shocked about it. I'll be like, what about weighting? And they're like, I don't want to talk about it. But the basic idea with weighting is, very, very quickly, is that you weight based on, there's no correct weight, all right? To the degree that you can specify a correct weight, it has to be based on prior assumptions about what you want to do. If you weight any one measure higher, it will predict that measure better in the future than it will the other measures that you weight lower, right? So the idea of a kind of correct weight is based on assumptions about what you're trying to achieve with your evaluation system. I would also point out very quickly that there are alternatives to weighting. A lot of states are doing it in this way where you just combine things in this weighted average percentage, but there are alternatives to this. Doug Harris and other people have proposed using value added as this kind of noisy screening device, whereby teachers who get low value added scores in 1 year are kind of set aside and subjected to additional intensive observation and other types of interventions, so no decisions are made based on value added scores, but it is a screen at the beginning to identify teachers. And we can talk about that more if you'd like. All right, so now we're done.
A lot of our locals have that matrix with value added versus observation.
That's a somewhat
Same
plausible,
idea.
yeah, I mean, it's a plausible alternative. Though, I mean, those matrices also imply weights, right? They're just not stated specifically. But yes, it is a similar idea. Anyway, all of this technical talk is important, what we've been discussing, and things can be done about it. But in the end, what matters is how teachers respond to using value added in their evaluations. It's this idea of kind of perverse incentives, which is a term that describes my teenage years, but it's also this idea that you don't want to encourage bad behavior. And if teachers respond in a certain way, you can have a perfect system. Value added is in there perfectly. Everything fits together perfectly. The system will not have the desired effect if teachers don't react positively. The unfortunate truth here is that the evidence on how teachers react is extraordinarily thin, in part because all of this stuff is new. So there are all these risks. It's not going to help teachers improve. They'll be teaching to the test. Teachers will switch schools and classrooms. Teachers won't choose the profession in the first place, so on and so forth. So we have evidence that evaluations can help. We have evidence that principals pay attention to value-added scores, whereas teachers don't really in a low-stakes context. But beyond that, the evidence is extraordinarily thin. Now, I can't tell you how this is going to turn out. You're probably in a better position to tell me. It's going to unfold over the years. I think that there are, a dozen or two kind of common sense suggestions. I've just listed a few of them here that are they're a little vague, but, for example, if you want to know what teachers are thinking about value added or how they're reacting, you might ask them. That's just spitballing. And I'm not talking about like the Survey Monkey thing where it's voluntary and there's all kinds of selection bias in who answers and who doesn't. I'm talking about a survey that's at least checked for representativeness. That's expensive, but I would argue a very good investment. I think we're learning now that using school-wide value added is not working out. I mean, this was a good example of something that, in retrospect, it shouldn't have been tried. This is where you put like 10% based on school value added for teachers in their individual teacher evaluations. They get a score. Part of it is for how their school did on value added. This is something that I think probably doesn't sound great in retrospect, because teachers are just coming and saying, so let me get this straight. I'm being held accountable for the performance of students that were never in my class. And everyone's kind of going, yeah, that doesn't make any sense. And for Christ's sake, I won't go through all of these, but take your time. If you're lucky enough to be in earlier phases here, this is not a race, all right? You hear people say, kids can't wait for new evaluations. Kids can wait for good policy, okay? Take your time with this. 2 years for design, a year or two for piloting. Some states are doing this, some districts are doing this, others are kind of rushing, but take your time, let people get used to these things before full-blown interpretation. But anyway, the idea here is that accountability systems are about changing behavior, and that's really what's going to determine the outcome of these new evaluations, and pretty much anything that's designed to address productive behavioral changes or encourage them amongst teachers under these new evaluations, I'm all for. This is just a review of some of the recommendations. Like I said, this is not exhaustive or even close to exhaustive, but these are what we've discussed here. I only have so much time, so I can't go into too much detail. There are dozens and dozens of things I think you should read. If you're going to start somewhere, I would strongly recommend Doug Harris's book. He wrote, it's comprehensive, it's perfectly accessible. It covers a lot of bases about testing in general, about value added, about the use of value added, and I would strongly recommend that you read it. Carnegie Knowledge Network also has a bunch of briefs. They're great, written by different people. And again, this presentation will be available on your app soon. It's also on the Schenker website. But anyway, what I'm just trying to say in closing, I'm sorry for rushing, is value added is neither like the horror show that its opponents suggest, nor this kind of golden ticket to Finland that its supporters sometimes argue. It's just a tool and one that should be used properly. Its impact, by the way, in evaluations will be very tough to identify, right? Because we can say whether evaluations had an effect, but not whether they would have had a different effect if there were no value added, right? Or if value added were different. It's very tough to split that up by component. But again, all of the technical discussion about validity and reliability is very important, very much related to how teachers respond to it. But in the end, this is kind of all up to you guys about how you respond to the incentives of the systems. And if you walk away with one idea here, is that this is a very nuanced situation, and I really wouldn't be super certain in either direction at this point. And so that's what I hope you said, and that is all. And I'm really sorry that we went over time, but we shall